We are told that a falling object which is dropped from rest covers a distance of s, which is equal to a half at squared. Now t is a variable, so t is a variable, and we say that the acceleration a is a parameter. Now we're told on Earth that the acceleration due to gravity is 9.8 meters per second squared, and we've been asked to work out a distance a body has fallen after 2 seconds and then after 6 seconds. So, looking on Earth, we're told that the acceleration due to gravity is 9.8 meters per second squared. So our s is a half times 9.8 times 2 squared. So that gives us a half times 9.8 times 4, and working all of that out we get 19.6. So after 2 seconds the displacement is 19.6 meters. We then need to work it out for after 6 seconds, so that gives us s is a half times 9.8 times 6 squared this time. So that gives us a half times 9.8 times 36, and working that out we get 176.4. Therefore the displacement is 176.4 meters after 6 seconds. Now in the second part of the question, we're told that the experiment is carried out on Ganymede, which is a moon of Jupiter, where acceleration due to gravity is 1.4 meters per second squared. And the question again wants us to find the height fallen after 2 seconds and after 6 seconds. So we know that on Ganymede, the acceleration due to gravity is 1.4 meters per second squared. So our displacement after 2 seconds is a half times 1.4 this time times 2 all squared. So working that out we get a half times 1.4 times 4, so that gives us 2.8. Therefore our displacement is 2.8 meters, and that's after 2 seconds. So the last thing we need to work out is the displacement after 6 seconds, so we get that s is a half times 1.4 times 6 all squared. So that's a half times 1.4 times 36, and that gives us 25.2. So therefore our displacement is 25.2 meters when it has fallen for 6 seconds.